growing interest on quantum communication and its importance. The purpose of this workshop is clearly mentioned in our brochure. This is to introduce quantum communication and also its role in secure communication. Regarding sessions are going to be handled by industry experts and eminent professors. So I encourage all the participants to actively participate in all sessions, interact with our experts, and also interact with our coordinators, clarify your doubts. At this workshop, it should be a platform for learning, collaboration, and inspiration. And I would like to appreciate Dr. Sudarshan and Dr. Mageshwaran for their efforts and dedication and hard work in organizing this workshop. Their dedication and planning made this workshop a successful one. Once again, welcome to the workshop and thank you all for being here. I wish all the participants for fruitful workshop and the enriching session. Thank you all. Thank you very much.
Thank you so much, ma'am, for your thoughtful and encouraging words. It is, it is a privilege to introduce our esteemed chief guest for the day, Dr. L. Venkata Subramaniam, Quantum India lead at Quantum India Organization. Dr. Venkata Subramaniam obtained his BTech degree from PES Engineering College, Mandya. He did his master's from Washington University, St. Louis, and did his doctoral research at IIT Delhi. He joined IBM as research staff member in 1998 and rose through the ranks to become the head of IBM Quantum India in 2023. He is recognized among India's 100 most influential people in AI by Analytics India magazine and in the MIT Sloan Management Review in Top 100. He was also featured by Mint as one of the four musketeers of India's quantum leap. These recognitions reflect his work in quantum computing and artificial intelligence and his sustained efforts to position India as a global leader in these transformative fields. He holds 38 patents and has authored over 150 research papers, in addition to architecting several advanced products during his tenure as head of IBM Quantum India. His book Quantum Nation, an Amazon bestseller, aims to inspire new generation to explore India's quantum future. In November 2025, he joined Quantum India organization and plays a key role in establishing a quantum valley at Amravati in collaboration with the government of Andhra Pradesh. We are privileged to have him with us today. Please join me in welcoming Dr. L. Venkata Subramaniam to address the gathering.
Thank you. Thank you so much. It's such an honor to be here. Thank you to the other speakers also, ma'am, sir. It's really a privilege that you invited me today to join you and to talk to all of the participants here. It's very great to see that, 500 people have registered and over 200 people are right now joined this talk here at this point, the inauguration. And it really, what it goes to show is that quantum today is a very, very interesting topic with a lot of potential. Okay, lots of potential, and not only in India, but across the world. Quantum is one topic which has generated so much interest, whether it is startups, whether it is governments, whether it is industry, whether it is students, faculty, across the board. There is a lot of interest because of the potential that quantum computing has. Okay. And it's really very good that all of you here have joined today and are going to take part in this week-long sessions of from various experts across the country. All I will say to each one of you is that here is one homework for you. Okay, so I know all of you will learn a lot of good things from this sessions that are being planned for you, that have been planned for you. I want each one of you, at the end of every day, to please go to Wikipedia and add one or two lines from any of the topics that you found interesting, please add your thoughts on Wikipedia. Just read that page. Let us say today somebody is going to talk about India's national quantum mission, or about what is quantum communications, or someone talks about quantum key distribution, for example. If someone talks about quantum key distribution, please go to the quantum key distribution page on Wikipedia and read it and see if there is something that you learned which you can add there, okay, to that page. Even if it is just one line or two lines, that is enough. But at the end of the day, please go to any of the relevant Wikipedia pages and add something from what you have learned, okay. That will really, first of all, it will add to your own knowledge, number one. And second is, you will spread your knowledge to others, okay, to the others who are now looking at those pages or trying to learn. So it is very important that you not only learn, but you use your learning also to share with others, okay, whether it is on Wikipedia. To begin with, it's going to be Wikipedia, but let us do it through other means also, which I will talk to you, okay. So I will stop here because I have a talk now with you, all of you. Today I'll be giving a talk as part of this, after this inauguration. But I just want to tell you that, first of all, congratulate each one of you for joining this course and signing up to learn. And as part of this learning, I can tell you that this is going to be a very exciting journey. There are a lot of new things happening in this field, and you are now entering one field as a pioneer. You are now entering quantum as a pioneer, because across the world, there are not too many people who today have learned much about quantum. Okay, so you are one of the first people, and you will go on to contribute great things to this field. So, first of all, congratulations. And as I said, use your learning, share it on Wikipedia, and we'll also talk about some projects when I come back to give you the talk. So, thank you so much. Thank you to the organizers also, and congratulations to the organizers for doing this session, which is very important. And we will see soon why it is important in the talk that I will give. So thank you so much. I will stop here.
Thank you so much, sir. Thank you so much for the insightful and inspiring speech. Your presence has truly enriched us in this occasion. As we come to an end for the inaugural ceremony, I now invite our program co-coordinator, Dr. Maheshwaran, to deliver the vote of thanks.
Yeah, thank you, Swarnima. Good evening, everyone. It is my distinct pleasure and privilege to propose vote of thanks on behalf of the organizing committee for the 6-day online ATAL FDP on quantum communication, recent progress and future research directions. First and foremost, heartfelt thanks to our esteemed chief guest, Dr. L. Venkata Subramaniam, Quantum India lead at Quantum India Org, for gracing the occasion with his inspiring presence and invaluable insights. He also has a book which is very popular in Amazon, so you can just check it in the website for more details. And I also extend my sincere gratitude to our Honorable Director, Dr. G. Agila, NIT Tiruchirappalli, for her constant vision and unwavering support, which is our guiding force. And also a special thanks to our head of the department, Dr. R. Pandishwari ma'am, for encouraging such initiatives that foster faculty development. And all of these are going in a good organized manner, and for that I have to thank my entire organizing team, the technical team and support staff for their meticulous planning and tireless efforts and seamless execution. And to our administration, IT team, and volunteers, your behind the scene works are actually ensuring everything runs smoothly in this workshop and FDP. And for the participants, this FDP as the chief guest, Dr. L. Venkata Subramaniam stated, not many people work in this domain, and it's a very important area of research because future, most of the data centers and communications will be based on quantum computing and quantum communication. So this is a very important topic. So I hope at the end of the 6-day FDP program, you will gain much more insights into the finer details of this niche area. And hopefully this program will enrich our experience in this domain. So thank you all. Thank you once again for everybody for participating. So with that concluding remarks, I leave the floor to the chief guest and also speaker of this session, Dr. L. Venkata Subramaniam, for the talk. Thank you, sir. Thank you for accepting our request.
Thank you. Thank you so much, sir.
Thank you, sir. Thank you for expressing our gratitude. With this, we bring our inauguration to a close and eagerly look forward to an engaging week ahead. Let us now begin with the first session with the much anticipated talk by our chief guest, Dr. L. Venkata Subramaniam. Thank you, everyone. Thank you, everyone, and have a wonderful evening ahead and a wonderful session for the next 6 days. Sir, you have been made the presenter for the next session.
Thank you.
Thank you so much, sir.
Okay. So good evening, everyone, and it's really an honor to be here in front of all of you and to talk to you about quantum in general. Okay, so I know this this FDP is about quantum communications, and that's what you will be learning from the experts. But my role today is to give you a sort of an overview. Okay, I will talk about all the aspects here: quantum communications, quantum sensing, quantum materials, quantum computing, and all of this. Okay, because what I want to do today is to give you this broad overview. Okay, is there some noise? Somebody wrote that there is some noise. Is it okay? Okay, fine. Thank you. Because some message I just saw. Okay, that's fine. So I want to now tell you about the quantum decade. And we are specifically going to talk about India's leap forward. Okay. Now, this figure which I am showing you here, this is a professor at AICTE Pune. Okay. And this is a quantum. Okay, I hope you can see this. So this is a quantum phase transition experiment that Professor Umakant Rapol performed in his lab. Okay, recently, one day I just saw a WhatsApp message from Professor Umakant Rapol saying that, here, Venkat, look, I was able to perform this phase transition experiment. And what is this phase transition experiment? Here he has trapped some ions. Okay, he's taken some ions in a vacuum chamber, and using lasers, he has trapped them and he's observing their phase transition. Okay, now why am I showing this to you? I'm showing this to you to make the point that across India today, like Professor Umakant Rapol, many professors, many industries, many startups are working on very exciting things. And today, you are also beginning your journey into this exciting field of quantum. Okay, that's what you're beginning to do. And over this week, you will learn a lot of things about quantum communications. But today, as I said, I'm going to give you a broader overview of what is quantum, what are the things under quantum. Okay. So I'll start with one, very interesting thing, which is, we all know about supercomputers, right? So across these years, we have learnt about, we all use computers, and on our computers, there are CPUs, and now we also have GPUs, and putting these together in these supercomputers, multiple GPUs are there. So for example, this particular Summit supercomputer, which is now, I don't know, it's like the 10th fastest or 10th most powerful. At one time, it was the most powerful. It could do 200 quadrillion calculations per second. It had NVIDIA GPUs 27,000. There were also some IBM power processors here. And it was running the Linux operating system, right? And this is one example of a supercomputer, okay? And as I said, there are multiple supercomputers in the world, including in India, the Param series from CDAC. These are all very powerful computers, but there are things that supercomputers also cannot do. So I'm going to give you some examples of such problems, and also please feel free to write on the chat box. I mean, to write any questions that you might have. We'll try and keep it as interactive as possible. Okay, so please feel free to ask any questions in between also. Okay. um, okay, so I told you we're going to look at three problems where quantum computers are, or at least supercomputers can't do much in that. So what are these three problems? There are three examples. So one is caffeine. Caffeine is a small molecule. This is the formula for caffeine. Nitrogen, oxygen, all these molecules are there. Okay. And caffeine, as you know, is found in many of the drinks like coffee. It's there. It's there in some of the soft drinks also. Um, and this caffeine, if you wanted to model this caffeine molecule for one fraction of a second, then how do you do it? If you wanted to understand where are the atoms, where are the molecules in this caffeine molecule for one fraction of a second, can you do it on a supercomputer or any computer today? To do this, get the energy. Okay. And okay, fine. I hope I am not muted. Okay, I'm still unmuted. So to be able to represent the energy configuration of a single caffeine molecule at a single instant on a computer, any supercomputer or any computer, the biggest computer, you would require 10 to the power 48 bits, which is like 10% of the total number of atoms present on Earth. And we don't have a supercomputer that big. It's not there, doesn't exist. So if we wanted to model the caffeine molecule for even a fraction of a second, unfortunately, we can't do it. It's not possible. You cannot model this molecule. It's in fact a small molecule of nature. Okay. But on a quantum computer, you can model these molecules using what are called qubits. Qubits, bits in computers, qubits on quantum computers. This is full screen. Somebody said, can we share full screen? This is full screen. Now all you can do is increase the size of your own screen, because from my side it's full screen. Okay, so I hope everyone is seeing my slides full screen. Okay.
Yes, sir. Yes.
Why is modeling molecules important? Modeling of molecules is important because what is a medicine? In your body you have proteins. Medicine is something which goes, and if one of the proteins loses its shape, for example, a protein which is supposed to be shaped like this, if it becomes like this, then medicine is something which goes and fixes that. Okay. Now today, if you wanted to find a medicine, it takes 5, 10, 15 years, primarily because you have to take the diseased protein in one test tube, the medicine molecule in one test tube, pour and observe. If you think it's working, then you take that molecule and get it tested on mouse. Then you take it to dog. Then you take it to monkey. Then you test it on humans. And all of this process takes several years. And that's because you cannot model molecules on computers today. You can't model them. You cannot simulate molecules, because we just saw that if you want to simulate the caffeine molecule, you have to have a computer, very big computer, which we don't have today. And hence you have to use what is a quantum computer. Okay. And another problem. Okay, so you all know what is factorization. What is the prime factors of 15? 3 into 5. What is the prime factors of 100? 2 into 5 into 2 into 5. What is the prime factor of 49? 7 into 7. What is the prime factors of 60? It is 2 into 3 into okay, whatever. So there is a question, how is modeling happening today? Okay, how is the modeling happening currently? Unfortunately, there isn't much modeling happening today. Okay, you can model some of the very small tiny molecules like hydrogen, but as you increase the size of the molecules like caffeine, you cannot model them. So there is no modeling happening. That is why, for example, when we try to, people have been searching for new kind of plastics which can degrade. For how many years have they been searching? For the past 20, 30 years. Okay. People have been saying plastic is polluting the earth. We need new plastic which is biodegradable. We cannot model molecules, so we are not able to find those new biodegradable plastic kind of molecules. Medicines, I just told you, if you want to find a new medicine, it takes 5, 10 years, because you have to first of all find these molecules. There are 10,000 molecules. You do various kind of testing. Then you take that molecule, test it against the culture in a test tube. Then you take it to mice. Then you take it to dog. You take it to monkey. Then you take it to human. That's the process we are following today, because there isn't much modeling you can do today on a computer. You have to resort to physical in vitro uh, you know processing of molecules and things. Okay, so I hope that answered your question, Manjunatha Babu. Okay, the second problem I was talking about is this thing about factorizing numbers. Okay. So if you want to factorize 100 into its prime factors, it is simple. 2 into 5 into 2 into 5. Done. But if you were to factorize a very large number, a 2048-bit integer, if you tried to factorize that integer number, very big number, it would take 7 billion years on the best supercomputer. Billion years, okay, longer than the duration of Earth or whatever, right? It's very, 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 very long. Okay, you cannot, so hence you cannot factorize number computers today. Peter Shor in 1994 showed that factorization of the same 2048-bit integer, which takes 7 billion years on a classical computer, can be done in a few hours on a quantum computer. So he showed that there exists an algorithm where if you have a quantum computer with sufficient number of bits, qubits, then that computer can process your number and extract the prime numbers. Now, why is this very important? This encryption today, called RSA encryption, is based on prime factorization. If you and I, you know what happened in this communication, we are all on Zoom. From my side, one key was generated, which is a large prime number. From your side, one large prime number key was generated. Those two numbers were multiplied, and that became the key for this encryption of this conversation that we are having, this communication that we are having. Now, if my neighbor sitting there outside in let's say he's sitting outside in the garden, and he wants to break into my conversation here, what I'm talking, and let's say he breaks into my Wi-Fi and is able to capture all the signals which are transmitted between my laptop here and your laptop there. Okay, some communication is happening at this point of time, right? There is a communication happening. You and I are communicating, and that communication is happening using encryption, right? Encryption is happening, and that encryption, as I told you, is using prime factorization. I mean, large prime numbers as the keys. Now, unless my neighbor has that key, all they will get is the signals which they cannot decrypt. Why can't they decrypt? Because if I even try to do decrypt on the largest supercomputer on the world, it will take 7 billion years. So it can't be done. So by that time, Earth will, I don't know what Earth will be doing by that time, right? So that is again one very powerful example of what quantum can do. Quantum can break into communication lines today's communication lines. Quantum can break into encryption today. Whatever communication is happening between you and me can be broken if quantum computers become powerful enough to run this Shor's algorithm. So your password, banking password, when you do your online transaction with your banking password, that online transaction is protected using this encryption, which I just told you about. Now, if quantum computers are there, they can break into that encryption. Okay. But are there powerful enough quantum computers to break into that today? They are not there. What Peter Shor showed in 1994 was that there is an algorithm. Mathematically, Peter showed that if you build a quantum computer powerful enough, then that can break into all the communications which is happening today using this RSA encryption and other kinds of encryption where prime numbers are used. Okay. So this was the second example of what quantum can do today, which is to break into all of the encryption, break into all the communication which is happening, break into and listen. Eavesdropping can then happen. Somebody just has to sit outside my house and capture all the Wi-Fi signals that are going through my router, and then they will just break into that. Okay. And they can listen to whatever conversations I'm having either on my phone line or on any of these lines, even if they are encrypted using prime numbers for the encryption. Any questions so far? So this is one big basis for, okay, somebody is on waiting list, please allow. Okay, I will say that to the organizers. Please allow, people apparently are on the waiting list, and okay, thank you. Okay.
Yes, sir, they have been allowed you.
Okay, thank you, sir. Yes. So now, this is a very, very, very important thing which will keep coming back through this week. Okay. Can also, yes, blockchain gone. So somebody just sent me a message. Okay. I will read you that message. Just give me a second, okay? I want to tell you how much people are now worried about this. And yes, so Jefferies strategist, Jefferies is one of the big investors. Jefferies strategist Christopher Wood is dropping Bitcoin from his model portfolio, and this is an investment portfolio, okay? So people invest in stocks and things like that. So Jefferies strategist Christopher Wood is dropping Bitcoin from his model portfolio due to worries that future quantum computers could crack its security, potentially leading to theft. He is shifting the funds to gold and gold mining stocks, seeing gold as a more reliable long-term store of value. So what does that mean? That means that blockchain could potentially be under attack in future, and if you own Bitcoin, your Bitcoin could be broken into and stolen. Okay, so that worry has already started. Okay, and this is one worry from investors. There is worry in the government that governments around us, we are surrounded by countries which are not very friendly to us, China, Pakistan. There is a fear that all our data today is getting collected by these people. They're just storing it and waiting for the quantum computers to become powerful enough to break into that. So they are eavesdropping into all the communications which is happening today, capturing whatever data they can so that they can then break into this as soon as a quantum computer is there which can break into this encryption. Okay, so all of the future communications is under threat. All of the future encryption, passwords, all of that is under threat. Quantum application areas of, and what are the current research? Yes, so I will come to that. That's a very good question. Somebody is asking what all can you use quantum things for, and we will come to that. But which is why it is this course that you are doing is critical. Okay, so I will tell you that cyber security is completely changing. Communications, I know many of you might also be looking at 5G, 6G, 7G, 8G, 9G, 10G, all of that. So one, communications is also changing. New protocols are coming, new frequencies are coming, new bandwidths are coming. But in addition, this new thing which is happening is this quantum is bringing new things into the picture. And this week you are going to learn about two things. Okay. Yes, store now and decrypt later. Exactly. So, and I think these are things you are going to learn. But how do you secure yourselves against this? So I will briefly tell you about two things that people do to secure themselves. One is called PQC, post-quantum cryptography. The second is called QKD, quantum key distribution. Okay. PQC, post-quantum cryptography, QKD, quantum key distribution. These are two ways to secure communication against the threat of quantum, breaking today's encryption, breaking today's communication, because it can eavesdrop and decrypt the data. If the computer is powerful, the quantum computer is powerful enough to run Shor's algorithm and Grover's algorithm and other kinds of algorithms, right? So in the news, you might keep seeing, almost every week, somebody or the other comes up saying that they have now got a new variant of Shor's which is able to break some of the RSA encryption. So RSA encryption is already under attack, which means communications is under attack. So I talked about PQC and QKD. Okay. Yeah, I'm not changing the slides. I will let you know when I change. Okay. So PQC is post-quantum cryptography, where instead of using this RSA encryption, you are using RSA encryption. Remember, what does it do? It uses large prime numbers. Instead of that, the new PQC standards, they use what is called lattice geometry numbers, where numbers are arranged in a lattice, and from there you are picking your keys. Okay, so at the end of this talk, I'm not going into any of the details here, but please go and look up PQC and QKD. And these are things which are going to show up through this week as you learn more. Okay. In PQC, you are changing the encryption. There is nothing quantum about PQC. PQC just is a new mathematics. Instead of using prime factorization, you are using lattice geometry to generate your keys. QKD, on the other hand, quantum key distribution, instead of generating keys like large prime numbers or multiples of prime numbers, in QKD, you are actually generating a quantum key, okay? And you are distributing this key across your, across places, right? Across your sender and receiver. So quantum key distribution and PQC, as I said, you're going to learn a bit more about it through this week. All I'm doing is introducing you to a few of these concepts at this point of time, okay? And that threat is because of quantum computers themselves. Shor's algorithm, which says that it can break into prime factors. It can generate prime factors of large numbers. What are other problems? What is AI? Can somebody type what is AI? What is artificial intelligence? Okay, I'm sure everyone here uses ChatGPT. Okay. Yes, mimic human intelligence. Okay, so that's very interesting. What is human intelligence? These are children here. Okay. These children, I mean, we were all children at one point of time. We all might be having children, or we might have young brothers, sisters, all of that. Intelligence is really about learning. All of us, when we were children, we learned things. We went to school, our parents taught us things. Our parents said many things, they taught us, our teachers taught, and we then started adding this knowledge, and we started becoming more and more learned and intelligent. Okay. Now I'm going to start with a very small example of learning for us. Artificial intelligence is really about learning. In AI, what do? You give examples to the computer and you ask the computer to learn. And this is exactly what we did when we were children. Our mother would have shown us a cat saying par, pune, okay. And after a while, a new pune comes on that side, the child says, Amma, puna par, okay. So for us, learning was also through examples. We learned through examples. Cat, dog. We learned about this is a mobile phone. How many examples did you need to learn about cat? When your mother said Pune and showed you one Pune, how many Punes did you have to see before you said, Amma, Pune pare? Did you need 1, 2, 5, 100, 200, 10,000, 100,000? How many do you think you needed? How many cats did you see before you were able to learn that this is a cat? Type some number. Quite a few. 1 or 2. 1, 10, 1. Okay, very good. So people saw as children, maybe you saw 1, maybe you saw 2, maybe you saw 10. Maximum, maybe you saw 100. Okay, I don't know. Maybe 100 is also too much. Probably we didn't need to see 100 Punes before we said Amma Pune. So, artificial intelligence, let us say we give it the same task. Go and learn about cats. How many cats do you think AI needs to see before it is able to say, this is a cat? Humans, we just discussed. We need 1, somebody needed 1, somebody needed 2, somebody said 10, whatever. Okay, so maximum, highest number I saw was 10. Okay. How many cats does artificial intelligence need to see before it recognizes cats? Some guesses? Anybody working in artificial intelligence here? Okay, 10,000. If we give best fit data, then it will recognize. Yeah, what is best fit data? What is that data? Best fit data is cats, right? Can you show dogs? If you show artificial intelligence lots of dogs, do you think it will learn cat? Yes, so we have to teach the computer. What is the way to teach the computer? How does AI system learn about cats?
Sir, pixels?
Yeah, pixels, okay. But it will only learn if you give it examples of cats today, okay. And today, artificial intelligence needs 10,000, sometimes 100,000 cats to learn cat. It needs to be given cat from this angle. It needs to be shown cat from this angle. Then you need to show it occluded cat before it learns cat. Children, 10 cats. AI, minimum 10,000 cats or 20,000 cats or 50,000 cats. And still, if you show AI a cake which is shaped like cat, AI will sometimes make a mistake and say, this is a cat. The child will always say, Amma, idu vandu cake. This is not a cat. So there is a big problem with AI today. You eat 2 rotis and you are good to go. Your intelligence needs 2 rotis or 2 plates of rice, 1 plate of dal, done, finished. AI today needs lots and lots and lots of examples to learn. And so on January 20th, when Donald Trump took over as the president, the first thing he did was to declare a power emergency, an energy emergency in the US. He said, for us to run our AI models, we need lots and lots of power. And today, if you look at tech companies, all the tech companies are buying nuclear power stations to run their models. The model has a very simple problem. Cat, you need 2 rotis, you can recognize cat after 10 examples. Somebody said 10. I'm taking the biggest number here. But you try training an AI system with 10 examples of cats. It's going to have 10% accuracy or even less. You show it different cats, yellow cat, blue cat, white cat, all sorts of cats before it's going to learn. It needs thousands and thousands of examples. And so AI has a problem. Human intelligence, and somebody said pixels. We'll come to that. Somebody said the problem is with pixels. Is your brain looking at pixels? What is a pixel? So the challenge of classical computers is zeros and ones. Zeros and ones are a problem. Everything in this world has been reduced to zeros and ones, and hence AI is struggling. It needs GPUs after GPUs. By some estimates, if we keep growing AI models the way we are growing them right now, without coming up with better models, the earth will be filled with power stations by the year 2028. So we will have power stations everywhere, lots and lots of power stations to power our AI. And the challenge is the cat problem. This cat problem is a big problem for AI. It needs lots and lots and lots and lots of data to train it. And quantum, we are seeing that sometimes the data it requires is much lesser, closer to the human, and that is primarily because the classical computer has reduced your cat to a string of zeros and ones. Somebody said pixels. This cat is represented using pixels. Those pixels are dots. This phone, for example, will be reduced into 5,000 dots. 1111 dot. On your screen, you are not seeing the actual phone, but you are seeing a dot representation of this phone. Okay, that's what those are pixels. Okay, now if you reduce the number of pixels, you get very grainy images. Okay, if I increase the number of pixels, you get very fine images. But communication, to transmit very fine images, you need lots of bandwidth. And that's why, for example, if you are on your mobile phone and taking a call, sometimes video will go away. It'll go away. Okay. But anyway, the point here is that our brain represents the analog data which is here, not as a string of zeros and ones. It is able to represent and
ఫీమేల్
infer from
అనుకున్నా
this
చూస్తే
data.
ఆయనే మాట్లాడుతుంది.
And That helps us to do processing of fewer examples. We can see fewer number of cats and learn about cats. So our intelligence is very efficient today. The artificial intelligence is not yet very efficient. Anybody here who does not use chat gpt? Okay, so chat gpt, as you know, if some of you, I don't know if you've seen the calculation, one query on Google consumes this much power. One query on chat gpt consumes lot more, several times more power, orders of magnitude more power. So, and that is primarily because of the cat problem. AI is not very efficient today. That algorithms are not efficient. And that's where quantum, the third problem, I told you about two things that quantum does quite a lot more efficiently. One was modeling of molecules like caffeine or other molecules. The second one problem I told you about is the problem of prime factorization. The third problem I'm telling you about now is intelligence, learning, which is the basis for artificial intelligence. And that we are seeing that quantum computers represent the data in a higher dimensional space, and they are able to do better inferencing and better storage and better understanding of the data as a result. And a lot of this is coming from the limit of the bits, okay, zeros and ones. Zeros and ones. Today you write a program, C, C++, Java, which is a higher level language, right? You write a program, and then what does the compiler do? The compiler takes that program and converts it into a string of zeros and ones. And those string of zeros and ones are what runs on your processor. That's what happens, right? Now, on a quantum computer, what happens? Is the programming language different? It's not different. You can use the same programming languages, but the compiler now no longer converts it into a string of zeros and ones, but it is now converting it into circuits where qubits are present. And qubits have these very special properties: superposition, entanglement, and interference. And these are the properties used in quantum computing. These are the properties which are used in quantum sensing, quantum materials, and quantum communications also. So QKD, for example, uses these properties to generate keys. And if there is a person who is trying to, if my neighbor is trying to break into my conversations here, is able to break into the Wi-Fi, then I am able to protect it using the quantum keys. Okay, so that's what is happening, and I hope you will learn through about this in the coming 5-6 days. But I do want to tell you that please go and look up what is the difference between classical computer and quantum computer. What is the difference between bit and qubit? Okay, so that you are able to go and go deeper and understand these things, to understand why you are thinking about using a quantum computer. What is special about these quantum qubits and quantum mechanics? Why is it used in communications? And what kind of advantages is the quantum giving you over the classical communication? Remember, I told you, Shores can potentially break into today's quantum communications. It can break into blockchain. It can break into your passwords. And hence, there is a need to protect all of that. And that's what you are going to be learning through this week. Okay. And I also showed you some examples of how quantum is very, very good at certain things like molecular simulation, like AI, representing and somebody talked, I saw in the chat, somebody talked about, building these boundaries, for AI, the classification. Somebody I saw talked about this classification. Now, these boundaries are more efficiently generated in the human brain, but now also the quantum we are seeing is sometimes much more efficient compared to the classical computer. So somebody I just saw in the chat asked, what is the maximum number of qubits? So it depends, okay? It depends on the modality of the qubits you are talking about. Qubits, remember, can be generated using light. Photons can be qubits. Ions can be qubits. Certain molecules can be qubits. So different kinds of qubits have different, counts. But superconducting qubits, which is what IBM, Google, QPA AI in India, Professor Vijay Raghavan in TIFR, they are all using what are called superconducting qubits. And in these superconducting qubits, people have now gone up to 100. Some have also crossed 1,000. But the most efficient processors today, there is the IBM 120 qubits, there is the Google 105 qubits. Then there is the Chinese talked about having a computer with 107 qubits. In India, QPA AI recently released their Kaveri chip, which is 64 qubits. Okay, so there are multiple numbers, but everyone is sort of close to close to 100 plus qubits at this point of time. Okay, somebody asked about interference. Okay, this is a different interference, I would say. I mean, it's called interference because you are using interference to generate likelihoods, okay, between signals. And what you are really saying is you want to amplify the correct answer and attenuate the wrong answer. So for that, you are using interference between multiple runs to decide what are the good likelihoods where the answer lies. Okay, so I will give you this very rough answer. Please go and look that up. I'm glad you asked this question, which means you will now go and find that answer also. Okay, so go and find that answer. Okay, so yes, now moving forward. So does this mean quantum is good at everything? Unfortunately, no. Quantum is not going to replace the classical computer because, for example, something like multiplication is much, much faster on a classical computer compared to a quantum computer. So going forward, you are going to have CPU, GPU, and QPU, and the communications. And you are going to learn about the communications later this week as you go on. The communications between these chips could also now become quantum communications, right? And we talked about PQC and QKD, and all of these can be utilized to do that communication, right? So, yes, I'll not go here. So one of the things in quantum is this notion of quantum advantage. Okay, what is quantum advantage? Quantum advantage is where you take a task. I don't know, many of you might have gone through this, maybe you have heard about Google's quantum supremacy, where they showed one random sampling example which can run on a which ran on their quantum computer in a few hours, but a few minutes. And if you were to run that on a classical supercomputer, the best supercomputer, they said it would take several thousands of years or some such thing. I forget now. Okay, so this was called the quantum supremacy experiment from Google. And but this task which they picked was random sampling. It doesn't have any practical value at this point of time. It was just taken as a task to show that there are some things which quantum computers today can run much faster compared to classical best supercomputers. Now, quantum advantage is when you are able to take some meaningful, useful task, like it can be some banking task, it can be some fraud detection task, it can be some medicine making task or molecular simulation task. It is about taking that and running it both on classical computer and quantum computer, and showing that on the quantum computer it runs much faster or much more cheaply or much more accurately compared to what is happening on the classical computer. So that's called quantum advantage. Okay. And even in communications, you are going to learn that India, under the National Quantum Mission, has targeted 2000 kilometers of quantum communication, that is between Chennai and Delhi. Okay, a line is being done, and that is being done by IIT Madras. Okay, IIT Madras is creating this line between Chennai and Delhi, this 2000 kilometer line, which will have fully quantum communication in it. Okay, which means it will have quantum key distribution also as part of it to protect that conversation or communication which is happening there. Okay, now in terms of where is India in all of this, I also want to give you this perspective on what is India doing, where are we as a country. Now, I want you all to guess, which country do you think has the maximum quantum talent today? Is it US? Is it China? Is it India? And in fact, the answer is right here in front of you in this graph. So in terms of the absolute number of graduates in quantum tech, India is the largest country. European Union, as you know, is multiple countries. And if you look at the usage of quantum over the cloud, because there are many quantum computers you can use over the cloud for free today. There are some by CDAC in India, then the IBM quantum computer. You can actually run programs on these quantum computers for free. And who is running the maximum such programs? Indians are among the top people using these computers. Okay. So talent is India's core strength. Today, India is where a lot of quantum talent is sitting. And in fact, I just heard that 500 people registered in this call. I think, I don't know how many people have joined now, but lots of people seem to have joined. And so India is one of the most exciting places where a lot of good FDPs like this one are taking place, and where people are getting trained. And these people are also using a lot of the quantum compute time. They are building systems, they're doing many things. And so India is where all this talent is sitting. Okay. So now what are we going to do with this talent? After you are all trained, what are you going to do with this? Because you will also now form part of this talent group. Once you get trained in quantum, you will be one of the few in the world who understand quantum communications, who understand what is quantum technologies. And hence, you will now add to that talent core of India. Okay, you are going to add to that talent core of India. But what are you going to do with that knowledge is the very important question for all of you, right? What are you going to do after you learn here? What are you going to go and do? 325 plus participants, right? So all of these participants, these 325 plus people who are here, once you learn, you become part of that elite group in the world. What is it that you will do with that knowledge which you have gained? That's the big question which all of us, the government wants to ask you. Sir, quantum line from Chennai to Delhi, it's going to be the common fiber, okay, the common fiber optics. So that line is going to be made from normal fiber optics. Maybe they might lay some special less noise fiber optics also, but nothing special. Okay, it is going to be the same fiber which you have, maybe better quality, because I hear a lot of our fiber that, for example, from your house to the 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 pole from where that connection might be coming, I hear many of these are have lot of cuts and all of that. Okay, so maybe they will have very good quality fiber, but it's the same fiber. Okay, now, so as I said, India has the maximum talent, and we are now training more talent compared to anywhere else. Okay, and so the National Quantum Mission NQM, announced in the year 2020 and cabinet approval in 2023 for a budget of 6,000 crores, called for proposals, and by September they launched hubs. What are hubs? So 43 institutions across India were selected, and these institutions are now getting part of the 6,000 crores. The 6,000 crores is getting distributed among these 43 institutions. Okay, and these 43 institutions are now doing research, and 4 hubs have been created. What are these 4 hubs? One is IIT Bombay. IIT Bombay is the hub for quantum sensing. ISC Bangalore. ISC Bangalore is the hub for quantum computing. IIT Delhi. IIT Delhi is the hub for quantum sensing. And IIT Madras, jointly with C. Delhi, are the hub for quantum communications. So the quantum communications hub is sitting right there in Tamil Nadu, in Chennai, in IIT Madras. Okay, and Trichy certainly now needs to become part of this group. And in fact, those of you who are interested, please at the end of this week, stay in touch, and we will now let you know how you can, become part of the National Quantum Mission. What can you do? What are those projects that you can do? What kind of hardware can you set up? If you don't have money for hardware, what kind of software projects can you do? Okay, so multiple possibilities are there. So please stay in touch, and we would really, really like you at the end of this course, 1 week, the 325 participants to not just take this training and go away, but at the end of this week, you need to start contributing to the National Quantum Mission. Okay, and if you don't know how to, we are very happy to help you. Think about things that you can do. You can start small, but you can then scale it up, become bigger and bigger and bigger. Yes, yes, please. In fact, Dipti Saxena, please, we are all very happy and keen that each one of you should participate in the National Quantum Mission, and we will think about ways in which you can participate. Just stay in touch, please stay in touch with the organizers, and we will be happy to let you know. And the speakers who are coming after this, we will talk, they will also give you tips. And Deepti Saxena ji, you have asked how can you join, and that's why, I told you, please stay in touch with the organizers, and we will let them know what are the ways in which you can start participating. Okay, now one way is, of course, to go and work with these institutes. Okay, each one, as I said, is working on different things. IIT Madras and C. Delhi are working on quantum communications. ISC Bangalore is working on quantum computing. So different institutes are working on different thematic areas, right? Now, in addition to this, the government is also supporting startups. Okay, in the first round, they supported 8 startups, but now they are calling more and more and more startups, saying that startups are welcome. Please come and we will help you get started. Okay, and they are in fact funding startups up to 25 crores. Each startup 25 crores. One startup can get up to 25 crores. Okay, so the opportunity is there now to think big, because there is big money now. Government is willing to give you money if you are able to come up with big ideas. So Deepti Saxena ji, please, if you have some good ideas, there is opportunity for you, of course, to get money for your institution, but there is also money now. If you have that idea and you have 2 students or 2 faculty or whoever coming together to build something, the government is also very happy to give you money to open your own startup. Okay, there is startup money also there. Third is, the government has also started under AICTE a minor program where quantum technologies open to all branches of engineering. If you do these 6 courses, you can now get a minor degree in quantum technologies. You can be a civil student, mechanical student, engineering, whatever student. Yes, sir, we have students group, but don't know how to start. Yes, please. That's what this FDP is all about. At the end of this week, you need to have some ideas to start. Okay. And that is why, in the inaugural, I told you at the end of this talk, whatever interests you, whatever, from whatever I talked about, if something interested you, please go to that Wikipedia page, read that up, and write 2 lines there about what you think should be happening or some knowledge that you have gained. You now have to come up with new ideas. Okay. At the end of this week, you would have learned a lot, but what are you going to do with that learning is very, very important. How many people here use Chat GPT? I suppose everybody uses Chat GPT. Who is the founder of Chat GPT? Okay, you can look that up. The founder is called Sam Altman. Yes, very good. Now, how much has Sam Altman studied? Yes, OpenAI, and Sam Altman is the founder. OpenAI is the company. Okay, now books or materials. Yes, books and materials we will share. Yes. So Sam Altman is a third year dropout. Third year. So I'm saying this to you to make the point that you don't need to be a PhD. You don't need to be a postdoc or whatever. If you feel that you have knowledge and you can use that knowledge to build something, that's all you need. Okay, that's all you need. And I told you just now, money is there. Government is giving money. In fact, investors are also giving money. A lot of there is money. Ilya and all, yes, they are all there. But remember, the guy who is driving it, the face behind it, the person who ideated, made it happen, is a third year dropout. If you need a Ilya, you can go to IIT and get those people, or go to Harvard or wherever you want to go and get them. But you need to start thinking, what is it you are going to build? I'm sure there are 100 things you can build. One project for every one of you. Let us say you are doing this semester signals and systems. I'm just making up a course. In signals and systems, let us say there are 4 textbooks. Now, can you build one Chat GPT like AI system trained on those 4 books, which can access, which can take the exam, the semester exam for that course and score more than you. So I hope the problem statement is clear. You have to take the 4 books on any of your courses, 2 books, 3 books, whatever number of books the course coordinator is using. Take those books, train an AI model. When the teacher gives an exam, give that exam paper to your AI. If that AI system, and the goal of your AI system is that that AI system should score more than you in that test. You also take that test. Let AI system also take that test. The AI system that you built has to score more than you. Okay, that's the goal. And how long does such an AI system take for you to build? You should be able to build an AI system like this in 1 week. You go to you go to YouTube. I'm sure many of you might have seen in YouTube recipes to build to make dal, rasam. Take imli water, add some rasam powder, add tomato, boil for 10 minutes. Recipe like that. Same kind of recipes are there for building these AI systems. Please build it. In 1 week, you can build this AI system which can go and answer your question paper. Okay. Maybe in the beginning, it's not going to score 100 out of 100. Maybe it will score 20 out of 100. I don't know, depending on what kind of things you did to build that AI system. But these are the things you need to be building. These are the things your students need to be building so that you can go and build a company like ChatGPT, like Sam Altman or Ilya or whoever it is who built these things. And that's really what we want in National Quantum Mission. Okay. I told you talent is sitting in India. But from India, we are not getting any of the products. Nobody is building products. People are just sitting and learning. Lot of talent, great talent. People are sitting and learning, but not using that learning to build anything. At the max, they go to Intel, they go to IBM, Microsoft, Google to the US and build for those companies there. Nobody is sitting and building anything here. Please look around you. There are hundreds of problems that we have. You can use AI, you can use quantum to build solutions to solve those problems. And that will make a great startup. And that will get funding for you from the National Quantum Mission. So go and build things that you can build, whether it's a quantum communication system, a quantum whatever system, there are things which you can build, and that will help us to solve a lot of the problems, and it will also help us to build products made in India. Okay. Any questions so far? To support this, there are multiple different states in India have now started very, very ambitious programs. In Amravati, in Andhra Pradesh, in May 2025, IBM and Tata Consultancy Services, TCS, announced their partnership to deploy one of the world's first quantum system 2. Okay, 100 plus qubit quantum computer, the best in the world, is coming to Amravati. Okay. And around this, the Amravati Quantum Valley Tech Park is saying that why did they call their thing Quantum Valley? They're calling it Quantum Valley because they are saying we are going to build something which is going to bring more value to Earth, to our country, to the whole of Earth, all the nations combined, better than Silicon Valley. Please suggest Quantum Funding Agency. Everybody is funding right now, quantum. You need to come with idea first. Please come with a big idea. Funding is not a problem. National Quantum Mission, State Quantum Mission of Tamil Nadu, Quantum Valley Tech Park, they're all sitting with money, waiting for you to come with idea. So please come with idea first, then you can take all the money that you need. I just told you, 25 crores. If you have a good problem, 25 crores is waiting for you. 8 startups were already given, and hundreds more will get money from the National Quantum Mission. So what you need is idea. Okay, what was this question? Somebody just asked something. There is a quantum summit in Gujarat. Yes. So there is multiple summits are happening in Bangalore. Just end of last year, there was a um, there was this this Quantum India Bengaluru, where they had Nobel laureates also coming. Okay, so multiple things are happening, and as I said, Amravati wants to build Quantum Valley that is going to be bigger, more valuable, economically more powerful compared to Silicon Valley. Okay, so that's their goal, to build Quantum Valley, and they have already started. And that's also one place. If you have a startup, they are willing to give you land, they are giving you funding, they are giving you free office, everything. Just go and take it. Just take it. Wait. Nobody, has to wait. If you have a good idea, there is money waiting for you. Go and pick it up. And this is their Quantum Valley facility which they are thinking of building. The construction has already begun for this, and as I said, this is the Quantum Valley, and in Quantum Valley they want to build the most economically, the biggest quantum systems should be sitting there. The next Microsoft, the next Google, the next Nvidia, the next ChatGPT or OpenAI has to come out of where? It has to come out of India. And that is why National Quantum Mission, Amravati Quantum Valley, and there is also Q City Bangalore, where they are also saying we are allocating land, we are giving money, we are giving office space, we want talent to come, and talent, please come and build here. That's what they are saying. Okay, so these are some of the opportunities. And then across India, somebody just pointed out that Gujarat is doing certain things. Uttar Pradesh, if somebody is from web development field and complete beginner, 5 years ago I did not know the Q of quantum. Okay, nothing. I knew nothing about quantum, zero knowledge about quantum. I had no knowledge. By registering for this course, this FDP, this is a great step. Okay, this is all I did. This is what I also did. I attended FDPs, I attended YouTube courses, I picked up some books, I went to Wikipedia and added my own knowledge there, saying that, oh, okay, this line here, I can add 2 more lines there. Then I've now started to build things. I left my IBM job. I was the head of IBM Quantum, and I'm now doing startups. Okay, that's what I'm doing, because there is so much opportunity, and each one of you should go and catch this opportunity. Each state, every state in India is now trying to get talent and enable them to build things, to do things, to make startups, to if you are a faculty, then to go and train people. Did I miss any chat? And how much their past experience of web development. See, web development is in everything. I'll give you an example. There were 2 companies. One company, and this company was called, okay, I'll not go to the names because there were 2 companies. One company was making the front end. Okay, beautiful front end. The other company, and that company was a small startup. All it had done was for a data management platform. It had built a beautiful front end with nice graphs and all of that on how to show the data. Okay. Then there was one big company. That big company, what did it do? It had lot of people, lot of developers, very smart people, and they had built the backend, the very powerful backend. Okay. Both of them go to one of the big banks. Okay. The big bank, what does it do? The big company which spent millions of dollars to do all that big back-end work, it got paid 1 million. The small company which did only the beautiful front end along with some connections into the back end to show analytics on the data got 20 million, 20x more money. So what did the big company do? The big company then went and asked the small company, we are willing to pay you. Are you willing to get acquired? Okay. So web and front ends and back ends and that full stack connection that you can do is one of the most powerful things, because we humans, we love to see things. That's why I'm using a slide here. And when I did not move my slide, somebody asked, oh, why are you not moving the slides? Because humans love to see visual representation. So you person who is building, sorry, I didn't catch your name. You are whoever you are, Akshit. Okay, Akshit Thakur. You are in a very good field. Fast web development. Yes. Please use that to create front ends for beautiful things that people are doing in the back end. Okay. So you have a very powerful role here. How to enroll in AICTE minor degree course? Your college is the one which will enroll you. But today, some very interesting things. So there are a lot of courses which have been going on. Okay. So there was a WISER course, Washington Institute of STEM Education, Entrepreneurship and Research. 50,000 students registered for that course from Andhra alone. Okay, 50,000. And that course is just about to finish. Today, you can still enroll for it for the next 3-4 days. NPTEL has started a course on quantum algorithms. Okay, that course has got 70,000 people who have registered. 70,000 people who are faculty, students, developers, everyone has registered for that course. And you can also go and enroll for that course. It's a free course, free. You can go and register today. But if you want to take an exam, that course is 1,000 rupees for the exam. Okay. And if you win the silver medal or the gold medal in that NPTEL course, the Chief Minister of Andhra Pradesh has said that he will personally felicitate you and call you for dinner or lunch or something and give you gifts. Okay. So I hope that is good motivation for you. The course started today on NPTEL, jointly offered by IBM and IIT Madras. Prabha Mandyam and Anupama Ray and Shesha Sai Raghunathan. These three people are offering this course on NPTEL, started today. So you can also register. But all of you, by registering for this FDP, have already shown a lot of intent. And as I said, by the end of this week, you're all going to become experts in this. Okay, you're all going to be people who are already at the top, at the best. Okay, you are people who are top of the, adding into this talent pool that we have. Okay, this talent pool that India has, this is special, and you are all part of this special talent pool. But now, by being part of this talent pool, you also now have to contribute either by doing research projects under NQM, opening startups, going and taking courses like this quantum technology minor program or the NPTEL course or the other so many free courses are there in quantum communication, quantum sensing. NPTEL itself has so many courses. Okay, quantum communication, after this 1 week, if you find it interesting, you can go and start doing your own quantum communications. Okay, please do that, please do that. Okay, it's very important. If you have interest to pursue this, and don't only pursue this, as Dipti ma'am asked, you need to start some small projects. And that's how I started. Remember, 5 years ago, I did not know the Q of quantum, nothing, zero knowledge. From there, now people consider me an expert. Okay, I have my own startups now. I'm doing several things. I'm now part of the National Quantum Mission. I'm advising some of the state governments also. And all of that is possible if you just put in the effort, and you have already put in that effort. Remember, today you have joined a course where for 6 days you are going to learn from a lot of experts. But remember, keep learning, but at some point, like Sam Altman, say that, okay, it's now time for me to go and build things. I am going to build the most valuable AI company. I am going to go and build something big. Okay, you need to do that. Before that, we need some training. Yes, so practical knowledge, you will get it this week. That's all. Finished. After that, it's all up to you. Okay, if you need some more knowledge, yes, please go pick it up. As I said, there is lots and lots of knowledge. Acquire as much knowledge as you want. But at the end of that knowledge gathering phase, go and use that knowledge to do something, to build something big. Okay. Uh, okay, then somebody asked me about the use cases earlier on. Okay, what are people working on? So across domains, okay, people are working in banking, automotive, chemicals, life sciences, healthcare. Across domains, people are working. People are using quantum computers. People are thinking of using quantum communications, quantum key distribution. So a lot of banking, for example. Here, people are looking at cyber security, and in cyber security, a lot of people are looking at quantum communications. Okay, so today, somebody just asked, okay, what can we do? Okay, so for example, today, all the banks in India, they are saying, okay, who can tell me how can quantum computers help our communications, help our fraud detection? Now, remember, who is going to go and solve their problem? It has to be one of us, right? We have to find that solution, and we have to go and solve that. And how do we do it? By learning ourselves. We have to learn, and we have started that journey of learning today. Today we have started that journey, and that journey is what is going to take us to that point where we now start going and solving these real industry problems. And if you are able to find one good problem, then you can open a startup. You can go and seek funding from Tamil Nadu state, mission. Or if you are not in Tamil Nadu, you are in some other state, you can go to that state. So all the states, or you can go to the center. Everywhere people are waiting for the talent to come and say that, okay, I've now learned something. I want to use this learning to build something at this point of time. Okay, so I think I'll stop here, and I will take questions because we just have about 10 or so minutes, right? So I want to stop here, and yes, and let's discuss. Okay, I want to discuss because I think many of you do seem to have lot of questions. But okay, before we do that, one more thing I want to share with you, okay, which is that today you look at any hardware, you look at this mobile phone, or you look at your laptop, anything you want. 5 countries control the supply chain. 5 countries, five. China, US, Taiwan, South Korea, Japan. But have Indians not contributed anything to this phone or to your laptop or to your software or to your operating system? In fact, Indians are the people who have provided talent across the world to all the big companies in sitting in these countries. Okay, so these countries control the supply chain, but the talent is all going from India to them. So Indians are the invisible people. We are the invisible people. We are not seen. We don't control the supply chain, but we are just the workers. We do the work. We go and do work across the world. We go and build for other companies. We go and build for Samsung. We go and build for TSMC. We go and build for Google. But we are invisible. We are not seen. Okay, we are just there. We sit in other countries. We sit in India and work for these countries. Okay, but that is exactly what the quantum mission wants to change. And that is why the quantum mission is also funding all of you to say that you can now build these things in India. And that is where, a lot of startups are now coming, which are building these things in India. Okay. So I'll stop here and we can now have a discussion. Okay. Any chat things? Okay. Sir, before that, we need some training and some practical knowledge. Yes, exactly. You need that. Okay. But you have to go and seek it out. Okay. And you sort it out today by coming to this lecture. You're going to attend all the lectures this whole week. So you are already seeking out that knowledge, and you now need to use that knowledge to build things. Okay, and that's why I'm saying start with going to Wikipedia and trying to write 2 lines there based on whatever you have learned. And if at the end of this week you're not able to write any lines on Wikipedia, what does that mean? It means whatever you learned was not much use. Recently, I registered for PhD at NIT Jamshedpur. I would like to do my research in quantum communication. Can I build project through simulation? If any free tools? Okay, see, quantum communications, yeah, you can do some simulations and stuff, but it will not be the greatest PhD in the world. Okay, it will not be. It will be some, I also did something kind of a PhD. You need some hardware for this. And my suggestion would be, one, to connect with us. We will suggest what are those hardware you might need, the initial hardware to get started. Or please go to one of the other places nearby. NIT Jamshedpur means in that map, there are other institutes which are probably closer to you, where you can go and start using their labs. In fact, please write to people in IIT Madras or in C. Delhi saying that, look, I'm doing my PhD in NIT Jamshedpur. I'm working on this problem and I want to do this experiment. Can I come to your lab for 1 week or 10 days or whatever and do this? Okay. Please do that. Many people will warmly welcome you also to come and do this. I know that, for example, NPL, National Physical Laboratory, looks for interns like you who can just come and work here for 6 months using their hardware and build things. Okay, so please don't just sit there and do simulation. You can do simulation if you're working on computing. You can do simulation if your problem is only a simulation problem. But if you are saying that I am going to build some quantum communication thing and I will just simulate, that doesn't make sense. Okay, so please go find places which will welcome you with a red carpet and say that please, Rama, Koteshwara Rao, please come and work in our lab. And in fact, they will also pay you for that duration when you work with them. So please do that. For all of you, this is a big opportunity where, as a country, we are looking for leaders like you who will put in the effort to learn, and then using that learning will go and build things for India. AICT minor degree course, AICT minor degree course, but specific detail not sure if are available. It is available. Many in Andhra, I don't know how many colleges, is it 500 colleges have already started these minor degree courses. Okay. Across the country, DST is funding 100 colleges to start labs for these AICT minor courses. MNIT Jaipur has been running 40-hour course, online FDPs for each of these minor courses. There are 11 courses, and they are registered, and that registration fee is very small, 500 rupees or some such amount. I don't know how much it is. Okay, it's a small amount. Okay, so please, this is your opportunity. There are lots of places where labs are open which will allow you to do their hardware, and then there is learning opportunity through the course you are doing this week and other courses where you can go and do this. Okay, some of our colleagues saying it is tough to publish papers. No, it is the easiest because it's a new area. Anything you do can lead to a research paper here. Okay, so this is a very, very easy area. Lots of money is there from the government. Lot of research publication opportunities are there. It's a great area to. Now if you go and try to publish a paper in AI in a good place, they will ask you for you without running your programs on lots and lots of GPUs. I don't know how many of you have access to lots and lots of GPUs. I don't know what you can even publish today in AI. But in quantum, there is lots of opportunity. Does quantum computing play any pivotal role in quantum photonics? Yes, of course. Quantum photonics, in fact, is one way to build quantum computers. And recently, Indian Institute of Science, Professor Chandrasekhar built India's first quantum photonic computer. Okay, quantum photonic computer was built there, and he is now looking at building bigger and bigger and bigger computers. He built 6 qubits, but now he's trying to build bigger. How to get enrolled and get minor degree? Okay, this minor degree will only be given by your own institute. Okay, so if you are a student, your institute has to have started a minor degree program. So AICT will, under AICT, any college can start this minor degree program, but your college needs to start it first. Only then you can enroll. Otherwise, as I said, you can go and enroll for the NPTEL courses, which are also available. You can finish them, and you can then, because at the end of the day, what do you want this degree for? You want it for having knowledge to open your own startup or to get a job in quantum computing. And all of that is possible even if you go and take the NPTEL courses and get a few gold medals or silver medals there. Then you are the best in the country and you can go and get any job that you like.
Good evening, sir. Jack Mar here.
Oh, hello, Jaikumar. How are you?
Very fine, sir. How are you?
I'm great and nice to see you here. And so Jaikumar, sir, okay, he's traveled across the country. One of the most dedicated teachers that I've seen. He even went to Nepal.
Thank you, sir.
So he goes and somebody asked, how do I get practical knowledge and all that? He's the person who will give you that practical knowledge. He can run things on a quantum computer. He can train you, and he can um, you know give you that knowledge. And somebody here is asking, some research problem statements can be discussed. Yes, lots and lots of research problem statements. And that one slide I showed you, where I said, okay, in banking there is this, in pharma there is this, in logistics there is this. Those are all problem statements. They are all problem statements. Go and look for data sets on Kaggle. Go and look for data sets with your local bank. Go and solve real problems. Once you start solving a real problem, that's a problem statement. Use a quantum computer, use a classical computer, start comparing them, doing better and better and better. And you have people like Jaykumar here who can easily guide you. Okay, so please stay in touch with the people that you are meeting here. Stay connected, and thank you so much. So I'll stop here.
So Sudarshan here, thanks a lot for your time. Thanks for this very insightful talk. We are highly indebted to you for taking at least 2 hours of your time. Amidst your very busy schedule, you told that you're traveling also. Thanks a lot, sir.
Thank you. I really enjoyed this session. Thank you for having me here. Lot of questions. That was nice to see. Please keep asking questions. Don't forget Wikipedia. Go and write 2 lines at least there from whatever you learn. Okay. And all the experts like Jaykumar and others who are going to come this week, they're all going to give you excellent training. After this week, once you have learned, you need to go and build things. Okay, that's when your real test starts. Once you gain this knowledge, go and use it. Okay, so thank you so much. Okay, bye sir. Thank you.
Bye, sir. Bye. Thank you.
Thanks a lot, sir. So now we have our next speaker, Dr. Jaykumar. I request our host, Hari Ganesh, to introduce our next speaker. Hari Ganesh, please carry on.
I take immense pleasure in welcoming Dr. Jaykumar Vaidyasankar, the founder and CEO of Anutantra Private Limited. He also serves as an IBM quantum educator and AWS accredited educator. He leverages his deep understanding of quantum computing and skill development to train the next wave of innovators. Anutantra Private Limited has provided consultancy and conducted over 300 plus quantum trainings, workshops, seminars, webinars, conferences at many prestigious institutes and universities all across India. To name a few, IIT Patna, NIT Trichy, IIIT Dharwad, Amrita University, VIT Vellore, MNIT Jaipur, IIT Jodhpur, Anna University, ISRO Trivandrum, Rao Satellite Center, etc. His role encompasses not just imparting knowledge, but also nurturing practical expertise in applied quantum computing, a critical competency in today's technology landscape. With his commitment to IBM Qiskit Advocates Program, IBM Quantum Qiskit community contributes significantly to quantum community's growth. He facilitates challenge-based learning and consistently applies machine learning principles to quantum computing projects, aiming to advance the field and empowers learners across the globe. It's a distinct pleasure to welcome Dr. Jaykumar Vaidyasankar to deliver his lecture today. Over to you, sir.
Thank you. Thank you so much. Good evening to all. It's my pleasure to be here. Thanks for inviting me in this wonderful platform. Let me share my screen. Is my screen is visible?
Yes, sir.
Yes, ma'am. Thank you. So in this session, we will introduce what are the basic timeline about my career in quantum and how you can build a career in quantum. Then we will deliver today's topic about Qiskit programming, which is used to design quantum circuit. So this is about my timeline in quantum. I completed diploma, BTech, masters, PhD in IT. So quantum is very new for me. So before 6 years, I attended one of the session from Dr. L. Venkata the previous speaker. So he is my mentor for past 6 years. So I started my career as IBM quantum educator. So I involved in so many challenges. Anybody above 18 years, they are able to enroll challenges. I'll take pointer to highlight things. So these are the challenges. These are the challenges. Anybody above 18 years, they able to enroll in these challenges. These challenges contains industry related problem or industry focused problem, what they are focusing. Okay. So based upon that problem statement, they will give tutorials. If you follow the tutorials, you're able to solve the challenges. Then you can focus on summer school. Each and every year, IBM Quantum is giving this summer school free of cost. Then you can look for certification. So this certification is very well renowned, very much shouting. So nearly 150 people from India clear this certification so far. So once you completed this certification, you can expect 2 lakh per month within India as a starting salary. So if you have 3 years of experience in US with the Python and this Qiskit framework, you can expect nearly 12 lakh to 17 lakh per month. So that is the demand available in the market. So once you have certification, you can look for advocate post. So I got advocate post before 4 years. So you need to be have 2 open source contribution along with the certification. Then you can become a Qiskit advocate post. Then you can look for 3 months internship. So if you're a student, if you're a faculty, so anybody can apply for certification, advocate, and internship. Once you completed internship, they will give you digital batch like this. Then if you're a faculty, if you're a I hope my voice is clear, audible. I double checked. So if it is not audible, please rejoin.
Yes, sir, it's
Yes.
audible, audible.
Yes, yes. If it is not audible, please rejoin. Then you can act like a mentor. So minimum 5 years of experience is needed for mentor. So these are the free IBM quantum courses. You can check. I'll share that link with you. So this is very good learning platform if you want to learn quantum. So most of you are very, very much beginner to this program. So that is why I'm sharing all this stuff. So go to this website. Go to this website. You can check view all courses.
Sorry, sir. Your voice is muted.
Is it audible, ma'am?
Yes.
Is it audible? Yeah. Thank you. Thank you. So go to this link. So I recommend each and every one of you to go for course 1, Basics of Quantum Information. Click Basics of Quantum Information. So I can see 4 subtopics: single system, multiple system, quantum circuit, entanglement in action. So click the first one, single system. So click introduction. So content will be displayed in this way. Content will be displayed in this way. So you can check video, YouTube video is there. So this course is taught by Professor John Waters. He is teaching quantum in Canada for past 30 years or 35 years. So if you are watching this video for 1 hour or 1.5 hours, you cannot get all the information. You will have so much of doubts because you are beginner. So you need to stop this video when you can't understand a single term. You need to pause. Then you need to go to Google, ChatGPT, book or reference. You need to do basic research about that particular topic. Once you got clear idea, then come back to video. So if you want to study quantum, you need to study step by step, slowly, gradually. So if you are very hurry in learning process, you cannot learn properly and you'll have frequency of doubts. So this is one way. Sorry. Second way, you can download these slides. You can take printout. So I will highlight if it is not visible. You can download slides and you can take printout. The third way, you can read text. But if you go further, it contains so much of mathematics. It contains equations. Okay. So what I recommend, so right click this page, click print and try to save as PDF. So try to do this method for each and every web link so that you cannot stare your monitor so much of time. So if you're reading through physical copy, okay, which is very feasible to study quantum because it contains so much of mathematics, equation, you need to flip back and forth. So it will be easier way if you study through hard copy. So this is my recommendation. So once you completed these 4 modules, so finally you can take exam. So this exam is free of cost. So this exam contains 20 questions and you need to answer 16 correctly. Once you clear this exam, they'll give a digital batch like this. So try to complete course as much as possible. Try to collect digital batch as much as possible. So more batch if you are acquiring, more recognition you will get from industry. So this is the first course I am recommending. In same way, you can complete so much of courses. So once you complete course 1, gradually you can go for course 2. So I recommend each and every one of you to complete course 1 and course 2. So they depicted 15 hours, but naturally it will take so much of time. So this is the average time. For students, it will take less time, but for faculty, it will take more time. The more the degree you have, the more knowledge you have, the more age you have, more the problem in learning quantum. Okay. For students, it might be easy. For faculty, more knowledge, they need to fight with their own intuitive system. So that is the problem with quantum. So once you completed, then you can go for quantum machine learning. So most of the time participants straight away they will ask, I want to learn quantum machine learning. So you cannot learn quantum machine learning directly. So you need to learn course 1, then course 2. So probably it will take 5 to 6 months. So once you complete it, then you come for quantum machine learning. So having machine learning knowledge is having advantage, but you cannot directly learn quantum machine learning. It contains so much of steps. Okay, sequence of steps. So once you completed these 3 courses, then you can go for quantum business foundation. If you are from MBA, if you are from business background, you can go for quantum business foundation or recommend this course for your friends. This course is very easy course. So one of the probable easiest course you can learn within 1 day, quantum business foundation. So next one, you can go for quantum safe cryptography. So if you're interested in cryptography, if you want to go for advanced level, this I will recommend. So if you want to teach quantum in your classroom, if you want to teach, then you can go for modules. So I'll share this link. If you're a lecturer, if you want to teach quantum as an elective, you can go for this. So all these courses are free. Whatever I said so far, everything is free of cost. So remember this. The certification only cost the global level certification. So Qiskit certification 2.x. This is costly. I won't say costly. It is worth enough to invest in this course. I'll share this link. So this certification costs nearly $100. So if you're applying from India, it costs $100, approximately 10,000 rupees. So remaining whatever I show in this web link, everything is free of cost. So is it clear? Any doubts until this? All these courses are free of cost. Whether this link is loading, the second link.
Yes, sir.
Yeah.
It is loaded.
Yeah. So if you come down, so it will contain all information about certification overview, objectives, how to prepare for exam, and how to register. It will give all the links, and you can go for guidelines. So it will take so much of time, so don't want to waste our time. So I want to follow from the previous talk. India's national quantum mission also allocated 6,000 crores to invest in this domain. So until 2030, we need to spend all this money. Okay, this money is very small when compared to developed countries. So India's national quantum mission fall into 4 categories: quantum computing, quantum communication, quantum sensing and metrology, quantum materials and devices. So it contains 4 important hubs. I will share this slide, so don't worry about this information. In your free time, you can search across all these institutes. So IIT Delhi stands for quantum materials, IIT Bombay for quantum sensing, IIC Bangalore for quantum computing, and IIT Madras for quantum communication. And one more institute I want to highlight. SCTS, so Society of Electronic Transaction, Chennai. It is located in Chennai. So they have quantum communication lab. So somebody asked about doing PhD in NIT Jamshedpur. So this is the beautiful location you are looking for. They have quantum communication lab. They are doing so much in quantum cryptography. So likewise, you look all these places, you go to their websites, you contact their professors, students, they will guide you in better way. Okay. So this is about Quantum Valley in Amaravati. So along with the L. Venkadan Subramaniam sir, you can see all these photos. So they allocated 4,000 crores. So setting up Quantum Valley in Amaravati in Andhra. So this is one facility I visited in IISER Pune, so which is based upon nuclear magnetic resonance. So this is my team. And this is their quantum computing lab. So this is based upon nuclear magnetic resonance. So the capacity is about 38 qubits. So each and every quantum computer have different architecture. According to the architecture, the application will vary. So this is one lab at IIC Bangalore I visited before 4 years. So which is based upon quantum optics. So if you are from physics, you can look for this lab. Within your institute, you can set up this lab in future. So this lab cost 3 crores and it took nearly 3 years to develop this lab. So this is one lab in IIC Bangalore, which is based upon cryogenic engine quantum lab. So this quantum processor is built within IIC team. So 4 qubit capacity. So remaining all these components imported from UK. So this is one facility in IISER Bhopal, so which is based upon diamond. So these diamond have nitrogen vacancy. So using this nitrogen vacancy, they are able to do computation and analysis.
Excuse me, sir.
Yes. Please put in mute. Thank you. So this is one workshop frequently happen ISER Bhopal. I stayed there for 1 week. Wonderful workshop, physical workshop, offline. So NPTEL workshop in ISER Bhopal. To note down. So each and every year they will call for. So this is one lab in IIT Kanpur, Quantum Optics and Entanglement Lab. So these are their lab instruments. So they invited me for recording a NPTEL workshop, course, so SWAYAM course. So in future they will upload. So this is the initiative taken by 3 IIT and 4 NIT. So majorly it is conducted by MNIT Jaipur. Most of you know about this. So they conducted up to 8 quantum series. So if any faculty having interest, please look over. So IIC Bangalore, each and every year they are conducting quantum workshop. So mostly 3rd week or last week of June. So look for this. So sponsored by Karnataka state government. Okay. So based upon the demand, Indian government DST along with AICTE announced undergraduate course for quantum. So most of you keep on asking question in this topic. That is why I'm sharing all these details. So this is the committee. They have curriculum. So if you Google AICTE Quantum Technologies Model Curriculum, you will get this PDF. So this PDF contains about 36 pages. So this course contains 13 credits, about 11 courses. So any faculty attending 6 FDP, what I'm showing in MNIT Jaipur, so you'll get PG diploma in quantum technology awarded by AICTE. Okay, in future, they will host all these 13 courses, all these 11 courses recorded in various IIT facility. Okay, they will upload in SWAYAM NPTEL. Okay, what they will do, if any students able to register 6 courses, able to complete 6 courses completely, they will get minor degree in quantum. So this program is circulated by AICTE. Your institute need to apply for this. So normally it will come under top 100 institute under NIRF ranking. So don't hurry up. So future they will open for all institute. So this is for first pilot project. So only for 100 institute they will open. If your institute is autonomous, if your institute is university, okay, you can introduce minor degree in quantum. So this is what Venkata Subramanian sir is mentioning about. So if your institute is autonomous, you can offer elective courses. So all the syllabus is in online in AICTE website. So go to this page, download the syllabus, check whether you have faculty, check whether you have facility. Okay, if it is not, enroll yourself for this all this FDP. Okay, you will get minor PG diploma through AICTE. Once you have PG diploma, you can apply for fundings. So this is compulsory. Okay, if you are not having eligible, if you don't have any background in quantum, you can earn that PG diploma through online FDPs. So 18 courses, 18 credits. So any faculty completing 6, any students completing 6, you will get proper recognition from AICTE. So this is about our startup Anutandra. So we are located in multiple places: Chennai, Bangalore, Salem, and Delhi. So Anutandra means Anu means subatomic particle, Tantra means techniques. So we are dealing with quantum techniques. So this is about our team. So today we're going to see about IBM quantum platform. This is our objective, to do a small quantum circuit. So we'll go through basics before that. I hope my screen is visible. I'm moving to Blocksphere. So Blocksphere this is the basic visualization unit for a quantum bit. So this block sphere contains radius equal to 1, which is a unit sphere.
Shiva.
Please check your voice. Somebody is talking. Please mute. This block sphere is divided into two hemisphere, two-level system to represent binary system. So that is why we are dividing into two. So we have binary data. All our binary data encoded into quantum bit. So that is why we have chosen two level. Suppose in future you can divide into 3 level, you can divide into 4 level. If you are able to divide into 10 level, directly you can feed your decimal number. So that is possible in quantum. So in binary we got stuck. Only 2 level of information we are able to feed for our classical digital circuit. But in future you can increase this input base. Okay. So this you need to remember. So this block sphere contains a origin. From that origin, we are having a 3-axis Cartesian coordinates x, y, z, like classical. Okay, so we have two polar points. Excuse me. So we have two polar points. So one point in North Pole, one point in South Pole. So North Pole is extreme for Northern Hemisphere. South Pole is extreme for Southern Hemisphere. So we have two states, state 0 and state 1, because we are mapping the binary information in qubit. So that is why we pick only two states. So these two are called polar points, called pure state. So these are known value to us because we are converting binary value into quantum states. So we are taking a random point. So this green dot, imagine it is your location of your electron or photon or ion, any subatomic particle. So what we are doing, we are generating a vector from the origin. Okay. So we are generating a vector from origin. So this blue vector will represent the location about your quantum particle, or it will give information about your quantum particle. So this is your quantum state. This is your quantum state vector. So technically you want to specify quantum state vector. So this green dot is a mixed state. It is in between state 0 and state 1. Okay. State 1 and state 0. And we are slicing that Q sphere from the dot, which will lead to X dash and Y dash plane. So from this plane, from this point, what we are doing downside projection. So I'm taking pen, so it will be clear for you. So what we are doing a downside projection. Okay. So this will have some intersection. With XY plane. Okay. So from this intersection point, what we are doing one more projection. So this is projection 2. We are doing towards origin. So what we are doing towards origin. So I'll erase all the scribbles so you can focus. So we have a green dot. So green dot here quantum particle location. From that location, what we are doing two projections. So once you do two projections, you'll get a right angle triangle. So this is right angle triangle. So once you got a right angle triangle, you can apply trigonometry. So this is the point we are doing. So once you got a right angle triangle, you can apply trigonometry. Trigonometry means we are involved in angles. So what type of angles we'll get? We'll get angles between z-axis, here quantum state vector. So this is your first angle. So theta is between your z-axis and quantum state vector. So this is angle 1. Okay. So same way we'll get the second angle, psi 2. So this is your second angle, psi 2. So this is between your x-axis and downside projection. So we got two angles, one is theta, one is psi. Okay. So I'll revise all this concept. We'll revise. So this is very important. So this is your block sphere. Block sphere is to visualize your quantum bit. So block sphere starting with radius equal to 1 because unit sphere radius is equal to 1. So we are dividing into two hemisphere to represent binary system. Then we are having three axes x, y, z like Cartesian coordinate. We are picking two extreme points, North Pole and South Pole. So we are mapping our binary value to this quantum bit. So state 0, state 1 are opposite in nature. 0, 1 opposite, on, off opposite. So oppositely, if you want to map, you need to map two opposite polarities. So we are using this logic to represent pure states. So pure state is nothing but your binary value. So in between, you will have any combination between zeros and ones. So that is called mixed state. Mixed state is between state 0 and state 1. And this blue vector is originated from origin, okay, representing your quantum particle location. So this will give information about your quantum particle. Okay. So from this, we are mapping a x dash y dash plane. From that plane, we are doing two projections. From these two projections, we are making two angles. So once you have angle, you can apply trigonometry. So that is why we have this form. So we have Cartesian coordinate form xyz into polar coordinate form. So this is polar form. So write down this equation. Write down this equation. So this is called wave equation. This is called wave equation. This is your quantum particle. So this is your quantum particle. So quantum particle can be represented in the form of superposition. So it is the mixture of both state 0 and state 1. So we are adding state 0 and state 1. So look at here. So we are adding two components because it is in between. So in between means we need to add two components. So one is cos component, one is sine component. So cos component always related to state 0. Sine component always related to state 1. So we have two angles. So this is angle 1, theta, angle 1, angle 1. So this is angle 2, psi. This is angle 2, psi. So note down this equation. So for example, theta equal to 0. So recall previous slide. So this is about theta. This is about theta. Imagine if theta equal to 0, what happens? This particle will pointing to North Pole. So if theta equal to 0, there is no difference between your z-axis and your quantum state vector. So remember this state. So this is what happening over here. So theta equal to 0 means it is pointing to North Pole. There is no angle between your z-axis to your quantum state vector. So apply theta equal to 0, we will have two components. So we will have two components. So the cos component become 1, the sine component becomes 0. So 1 into state 0 will get state 0, 0 into state 1 will get 0. So you'll get only state 0. It means if you apply theta equal to 0, you'll get the same state. So it is equal to identity gate. It is equal to identity gate operation in classical. Also in quantum. So state retain as it is. State retain as it is. It won't move anywhere. It won't move anywhere. Okay. So this is the first example. Second example, what we are doing, we are applying theta equal to pi. So recall the previous equation. So apply theta equal to pi over here. You will get cos component becomes 0, whole component becomes 0. So 0 into state 0 plus this whole component become 1. So 1 into state 1, you will get state 1. So it means you will have rotation. So mathematically we will prove if we apply theta equal to pi from 0, from North Pole, it will go to South Pole. So this is equal to NOT operation, NOT gate operation. This is classical, right? So from classical, what you are doing, you have NOT gate. If you have NOT gate means if you apply 0, you'll get 1. If you apply 1, you'll get 0. Imagine you are in state 1. Imagine if you are in stage 1. What you are doing, if you are applying d equal to pi, what happens? Again, it will go back to stage 0. From 0, if you apply d equal to pi, it will come to 1. From state 1, if you apply d equal to pi, it will go back to stage 0. So I hope previous slide and this slide, everybody able to understand. So this is not operation in quantum. The next operation is d equal to pi by 2. If you apply d equal to pi by 2, what happens? It is in between. It is in between. It will go to equator. Okay. So 0 means, imagine d equal to 0 means North Pole. Okay. North Pole, stage 0. Okay. D equal to pi means it will come to South Pole, means state 1. D equal to pi by 2 means it will go to equator. It will go to equator. So this is the logic. So I can say it is the operation of half not operation, half not gate, half not gate. Not gate means the entire pi rotation, right? So half not gate means half of the not gate operation. So this gate is very important. This gate is very important. This gate, they will represent like Hadamard gate. This gate, they will represent like Hadamard gate. So that is why you have both 0 component as well as 1 component. And what is the ratio? 1 over root 2. You can rewrite this equation in this way. 1 over root 2 multiplied with state 0 plus state 1. So multiple ways you can represent Hadamard gate. It means it will create equal superposition. Equal superposition, not just superposition. It will create equal superposition. So why it is a equal superposition? Because it lies in the equator. So 50% away from 0. So 50%, sorry about that. So it is 50% away from 0. Okay, 50% away from 1, state 1. So that is the meaning. So we covered 3 principles. D equal to 0 means North Pole. D equal to pi means South Pole. D equal to pi by 2 means it is in equator, equal superposition. Okay, now we are focusing on second angle. So look at this equation. So this is the first angle, this is the second angle. Now you are in x-axis. So if you apply d equal to pi by 2, it will go to x-axis. Okay, from x-axis, if you apply d equal to pi by 2, psi equal to pi by 2, second angle, it means it will move from x-axis to y-axis. From x-axis to y-axis. So this is called phase gate. This is called phase gate. Okay, so x-axis contains real components. X-axis contains real components. Y-axis contains imaginary component. Imaginary component. So that is why we have I component in state 1 related to state 1. You cannot find I component in state 0. So I will erase all these scribbles. Now you can notice. So if you move from x-axis to y-axis, you will have imaginary component. Imaginary component. Okay. So we covered z-axis, state 0, state 1. We have covered x-axis, which contains positive state and negative state. So positive axis, positive state, negative axis, negative state in short form. So y-axis replaced into I, plus I and minus I. So if you have any point in your block sphere with these 3 pairs, you are able to represent in his block sphere. So I hope everybody able to follow. Now what we are doing, we are representing the state 0 in mathematical form. So this is the beauty about quantum. So you can have a physical realization and meaning of a matrix. So imagine a matrix. Imagine a matrix. So matrix contain your key sphere. Matrix contain your key sphere. So this is northern hemisphere. So this is southern hemisphere. Okay. So where stage 0 we mapped in North Pole. So where state 1 we mapped in South Pole, southern hemisphere. So look at stage 0. So stage 0 located in northern hemisphere. So that is why 1, if you mention, it means stage 0 exists in northern hemisphere. So that is why stage 0 map to northern hemisphere. So what is the relationship about state 1? State 1 is have no correlation between northern hemisphere. That is why we represent 0. So if you look at matrix of stage 0, you can represent the physical meaning of it. I hope everybody able to follow. Any doubts you can put in chat box. State 1 you can look. So the northern hemisphere doesn't do anything with state 1. That is why the 0 component for northern hemisphere, upper component, and 1 for state 1. So imagine you are representing the whole block sphere in terms of a matrix. So this is a column matrix. This is a column matrix. And this is H0. This is H0. H0 means it is column matrix. Okay. Now you are able to represent in opposite direction, which is called bra 0, which is called bra 0. So how will you represent bra 0 in mathematics? So in row form. So 1 0. So which is nothing but transpose of H0. So this is equal to transpose of H0. So you can write a general formula, H equal to transpose of bra. Transpose of bra. Okay. So once you understand state 0 and state 1, now you can say how will you represent positive state. So positive state, it is in between both hemispheres. Both hemispheres. So that is why both components are 1. That is why both components are 1. And what is the ratio? 1 over root 2. Why 1 over root 2? Sin 45 cos 45 equals to 1 over root 2. Okay. So once you understand positive state, you can understand negative state. So look at the negative state. It exists opposite side of that sphere. So that is why the second component become negative to indicate opposite side. So once you understood stage 0, everything will follow easily. So everything have physical meaning. So in mathematics, in quantum, everything have physical realization. So y-axis, you can represent the second component as I. So minus I, you can represent the second component become minus I because opposite side of your y-axis, minus y. So collectively, you can view your Q-sphere or block sphere in terms of matrix. So visually, you can represent, also mathematically also you're able to represent block sphere. So if you want to have a workshop or interactive, go to this link. I'll share this link to you. So very good link if you want to have practice about Q-sphere. So this is very important if you want to learn quantum computing. So which is called group block. So go to the chat box. Please go to the chat box and let me know, are you able to click this link? Because I need to ensure I am audible. Are you listening? Okay, good. So go to this link. Go to this link. Thank you. Go to this link. So this is stage 0, state 1, which is called pure states, which is called pure states. So these two are pure states. Okay, when you need to prepare a quantum bit, you need to prepare with stage 0 and state 1. Okay, so X is not gate. X is not gate. So quickly I'll try to write all these gates. So X is not gate. Okay, Y is not gate along with not gate plus pi by 2 phase rotation. Okay, Z gate is phase change gate, so which is about pi rotation. Okay, Hadamard gate, what it will do, it will change pure state into superposition state. So what type of superposition it will create? It will create equal superposition. So this word is important. So Hadamard gate will create equal superposition because it will lead to equator. So this you need to remember. Okay, so all of you click stage 0, click X gate. So I try to write this state. So we are in stage 0. We applied X. X means not gate. Okay, X means not gate. What happened? It will lead to state 1. It will lead to state 1. It will lead to state 1. So that is why from stage 0, it moved to state 1. Okay. Now what do you do? Click state 1. Click X gate. It will move back to state 0. Okay. Now we are in state 1. If you apply X gate, it will move back to stage 0. It will move back to stage 0. I hope all of you able to follow. Now all of you click stage 0. All of you click stage 0. Stage 0. Click Y gate. Click Y gate and observe what happens. Observe what happens. It will move to state 1 plus pi by 2 rotation. I will show you. I am clicking Y gate. So it will move to stage 0 to state 1 like X gate plus pi by 2 rotation. So downside you can see this is the phase. So physically you cannot see phase, but downside you can see phase from 0 to pi by 2 apply. So this is special about Y gate. This is special about Y gate. So Y gate have additional effect of X gate, not gate, also phase rotation about pi by 2. Okay, from state 1 plus pi by 2 plus pi by 2. Okay, once again if you apply Y gate, it will lead to stage 0. It will lead to stage 0. So now check. Now check. Now it is in state 1 also with pi by 2 phase rotation. If you apply Y gate, it will move back to stage 0. So if you are attending this ATAL FDP, please attend through laptop or CPU. Otherwise, you cannot practice. So this is my humble advice. So all of you click stage 0. All of you click stage 0. Now we are in stage 0. Okay. Apply Z gate and observe what happens. So it will do nothing. So Z gate will act like identity gate. So note down this equation. So if we apply Z gate in stage 0, it will stay in stage 0. If we apply Z gate in state 1, it will go to minus state 1, which means 5 rotations, 5 phase rotation. Okay, from minus state 1, if we apply Z gate, it will go to state 1, positive state. So Z gate will act like phase gate or sign gate, sign change. We'll note down here. So Z gate will act like sign change or pi phase rotation. So pi phase rotation means 0 to pi, pi to 0. So look at here, it will move from positive state to negative state and negative state to positive state. So this is the theoretical explanation of Z gate. From 0, it will do nothing. It will act like identity. From 1, it will move to minus 1. From minus 1, it will move to positive 1, plus 1. So I am clicking stage 0. All of you click stage 0. Click Z gate. Observe nothing. Okay. So click state 1. All of you click state 1. Apply Z gate. You can see changes over here. From 0, it moved to pi. It means it moved positive state to negative state. Again, what do you do? From minus 1, apply Z gate. It will move to stage 0. I hope everybody able to follow right now. So all of you click stage 0. All of you click stage 0. Click H, Hadamard gate. From stage 0, if you apply Hadamard gate, it will create positive state. Means equal superposition. Equal superposition. Okay. From positive state, if you apply Hadamard, it will go back to stage 0. It will go back to stage 0. So check this. All of you click 0. All of you click 0. Click H gate, Hadamard gate. It will go back to positive state. From positive, if you click Hadamard again, it will go back to stage 0. From 0, it will come to positive if we apply Hadamard. From positive, if we apply Hadamard, it will go back to stage 0. So all these four gates has its own inverse. So what it means, if you apply 2x gate, if you apply 2y gate, if you apply 2z gate, if you apply 2 Hadamard gate, which will cancel each other. It will go back to original state. So note down this point. So this is about X gate, Y gate, Z gate, and Hadamard gate. Next, we're going to cover S dagger, T dagger. So S gate, what it will do, so click stage 0, all of you click stage 0. I will write stage 0. Okay, if you apply Hadamard, where it will go to positive state. From positive, if you apply S gate, it will go to I gate, positive I. Positive I means it will move to X axis to Y axis. pi/2 rotation in xy plane. Pi/2 rotation in xy plane. So this is what S-gate is doing. So pi/2 rotation it will do. So all of you note down. All of you note down. From zero, if you apply Hadamard, it will create equal superposition. Positive state in equator. From positive state, if we apply S-gate, it will go to I state, positive I. All of you click 0. All of you click 0. Okay. Click H-gate, comes to positive. Click S-gate after that. It will go to Y-axis, positive I. Positive I. So look down, you can see pi/2 rotation. Okay. From Y, again, if you apply S-gate, it will go to negative state. So this is very important property. So stage 0, if you apply Hadamard, it will go to positive state, x-axis. From positive state, if you apply S, it will go to positive I. Okay. From positive I, if you apply S, it will go to negative state. So 2 S-gate, if you apply, it will not cancel each other. It will not cancel each other like these 4 gates. So S-gate doesn't have own inverse. So if any quantum gate don't have own inverse, we need to create. That is why we are creating S dagger. So this is called S dagger. So this S dagger will do opposite for S gate. So we are in negative state. We are in negative state. So we are in negative state. Okay. All of you observe over here. We are in negative state. From negative state, if we apply S dagger, it will do opposite operation. S dagger, again it will come back to positive state. So each and every quantum gate operation should be reversible in nature, or it will be reversible in nature. If it is not reversible, you need to create reversible operation. So this is mandatory. So that is why each and every quantum operation are reversible. So you can do back propagation. So if you are doing any machine learning project, deep learning, you need to do back propagation. So this is possible in quantum very easily because of opposite. Okay. So all of you click stage 0. All of you click stage 0. So my pen is not working. Yes, now it is working. So all of you click stage 0. From stage 0, apply Hadamard. It go to positive state. From positive, if you apply S, okay, it will go to Y. So instead of S, what you can do? Instead of S, what you can do? So instead of S, what you can do? You can apply T gate. If you apply T gate, it will introduce pi/4 phase rotation. So which is between positive state and I state. So this is mathematical. I will show visually. So all of you click stage 0, apply Hadamard gate. It will come to positive state. From positive, click T gate. It will come in between. So this is pi/4 rotation. So this is pi/4 rotation. So 2T gate equal to 1 S gate. 2T gate equal to 1 S gate. Again, if you are applying T gate, it will go for positive I. So 2 T-gate operations are required. So where in case of yes, one S gate will do this. So one S gate will do this. So try to practice more and more in this web page, which is more important if you want to understand quantum. Okay. So most probably, if you are not able to visualize, you cannot understand what is happening in quantum. So somebody asked, what is the carrier path if I am web developer? So this is very good example for you. So this is made up of web application, right? So if you are making interactive application within the quantum computing, how to learn, how to visualize, this is the great platform for you. Okay. So if you go to this GitHub, you can find coding also. So based upon this, you can improve. You can improve. Group blotch. What you can say, GitHub. So if you want to have code, you can go for this web link also. So I'll share with you if you're interested in web development. So a lot of opportunities are there for each and every field. So not only for web, not only for web. Where I can go? Chat box. Where I can look for chat box? Yes. Yeah, I'll come to this. I'll come to this. So that is why I told first learn course 1. So once you learn course 1, then go for course 2. So once you completed course 2, go for quantum machine learning. So that is why most of the people are asking about quantum machine learning. So don't try to learn quantum machine learning directly. It is like trying to learn swimming in middle of the ocean. Very difficult. So you need to start from shore, right? In river also, we need to start from shore, not middle of the river. So here you can see introduction about quantum machine learning. Okay, they will gradually take you to what is your classical problem, how you can fit. So they will give classical machine learning. If you don't know classical machine learning, they will give some review. So gradually you can learn. Okay, then you can learn how to encode your data. So you have classical data, right? So you need to encode your classical data into quantum states. So they will gradually lead you. So directly, if you go for this course, you can't understand a simple paragraph. So it will be very tough for you without knowing basics of quantum. You cannot understand quantum machine learning. Okay. So for this, we have hands-on session today. So we have only half an hour left. Very difficult to cover, even though I tried to do a try for you. So I'll share this link. So please use your laptop or CPU. Yeah, here the chat box. So go to this composer, the last link I shared. Go to this composer. So I logged in. So without login also, you are able to use this tool. So to have a IBM quantum account, you need to have credit card. So credit card they will charge. You should be very careful if you are using IBM quantum. So per minute they will charge 9,000 rupees. So for first 10 minutes, they will give free of charge. Okay. So each minute they will charge 9,000 rupees. So all of you able to get this link, the same view what I'm showing you here, composer. So it will look like a musical composer, musical sheet. Okay, musical sheet. So what I will do, I will use open board. So this is one good tool. So if you're a lecturer, if you want to take some online session or offline session, so you can do interactive note sharing. open board, so you can download. It is open source. So if you click desktop option, you can interact with your application. You can easily write over here. Okay. So these four are called quantum bits or qubits. Okay. So this C4 is classical bit. The C4 is classical bit. So which is nothing but binary. Which is nothing but binary. Okay. So we have four quantum bits. We have four classical bits. So you can see probabilities, state vector, Q sphere. So these three are visualization. Okay. So right hand side, you can see, I can take pointer. Right hand side, you can see open quasim. So it is a coding platform. You can resize your window however you want. So in this way, I resized. Okay. So here you can see open quasim. It means what? Open quantum assembly. Here you can change to Qiskit also. So Qiskit stands for quantum information science toolkit. So this is the abbreviation of Qiskit. So this is the tool developed by framework developed by IBM. Okay. So here you can able to simulate. Here you able to run actual quantum system through cloud login. Okay. So these systems are located across the globe. So for accessing this system, they will charge 9,000 rupees per minute. So this is too costly. So you need to be very careful. So simulation you can do n number of times, no problem. So this is Python code. So this is Python code. If you know Python, you can understand. So what we are doing, we are creating a quantum register. We are creating a classical register. So we have four quantum register. We have four classical register. And line number 6, we are creating a quantum circuit. So quantum circuit, we are passing these numbers 4, 4. So our circuit name is circuit itself. So whatever you do with your circuit, you need to do with this circuit variable. So for understanding purpose, what we are doing, we are clicking Q0. We are selecting bin button. So this will delete qubit, quantum bit. So delete qubit, click Q0, delete bin button, click Q0, delete bin button. So we are keeping only one quantum bit for understanding purpose, for easier understanding. Okay. So click C4, click minus, click C3, click minus, click C2, click minus. Resize your window. Resize your window however you want. So we have one quantum bit, we have one classical bit. So we already covered what is the basics of a block sphere. Here we going to see about Q sphere. So difference between block sphere and Q sphere. So Q sphere, you can visualize multiple qubits. Okay. Block sphere only for single qubit. So this is the difference. So note down this. It will confuse you after some point of time. Okay. Even the Q sphere, you can view multiple qubits, but after a certain number of qubits, it will be very much complex. Okay. So initially, all the qubits in IBM Qiskit, by default, it is pointed to stage 0, prepared in stage 0. So note down, by default, in IBM Qiskit, IBM Quantum Qiskit, qubit is initialized to stage 0. So this is very important statement. Okay, because stage 0, state 1 are known state to us. binary state. Okay. So by default in IBM Qiskit, if you create a qubit, always started from state 0. So if it is started from state 0, what happens? If it is started from state 0, it means off state. So imagine this is electrical wire. This is electrical wire. Okay. In electrical wire, off state means no power supply. No power supply. Okay. It means no power supply over here. No power supply over here. So in block sphere, where we map stage 0 in northern hemisphere, north pole. So stage 0 pointing to northern hemisphere. So this is the visualization of this circuit. This is the visualization of this circuit. So we will erase all this stuff. So remember, if you create any qubit in IBM Quantum, always start with stage 0. 0 means off state. So this electrical wire doesn't have any power supply. So right side you can see a small disk. This is called phase disk. This is called phase disk. So note down, it is showing in gray color. It is showing in gray color. So real part 0, imaginary part 0. Probability of state 1 is 0% because pointing to north pole. So I want to remove this coding part. What I can do, I can go to view, I can go to panels, I can disable code editor. So likewise, I can change my window. I can change my window. So same way, I can go to view, I can go to panel, I can disable state vector. Go to view, go to panels, disable probabilities. So enable only the circuit on this block sphere, key sphere. So you can do in any way. So enable this phase angle. So I can highlight, enable this phase angle, enable this phase angle. So this is like identity gate. Okay, drag and drop I gate. It means you are starting from stage 0. So what is the identity gate? D equal to 0. It means the state will retain same. So after this identity gate, it will remain in same state, stage 0. I hope all of you able to follow. Okay. So if you want to know gate information, what you can do, you can click gate. You can click this I show information. So left side, you can see a description about your quantum gate. You can read this. So if you want to see definition, you can click this. Otherwise, you can close this. So how many identity gates if you are putting the quantum state retain as it is, it will do nothing. So it is classical, right? So it is classical. So click gate, press delete button, you are able to delete. Click this gate, press delete button, click this gate, press delete button, click this gate, okay, delete all this stuff. So you can resize this window also. So to understand your key sphere. Okay. Next, we're going to cover about NOT gate. The second gate is your NOT gate. So look at here, the second gate is your NOT gate. It will look like crosswire, right? So drag and drop. So click this NOT gate and drop over here. So what is the technical definition of NOT gate? We start with stage 0. Stage 0 means off state. Okay, this is NOT gate. So after NOT gate, what happened? It will change into on state. So on state means state 1. So how to understand to electrical form? So power supply will be there. Power supply will be there. Power supply will be there. So that is why it is moving from state 0 to state 1 because of X operation, not operation. So look at here. Look at here. your information is changed from gray color, it is turned into blue color. So look at the information, probability of state 1 is now 100%. So previously it is 0%. So this is how we need to comprehend. This is how we need to comprehend. So I'll erase all this stuff. We'll erase all this stuff. Okay. Now what we do, we deploy one more NOT gate. We deploy one more NOT gate. Okay. So we understand layer by layer. So we starting from stage 0, we applied NOT gate 1, NOT 1. So what happens? It will turn into state 1. In between power supply is there. Okay. We applied NOT gate 2, NOT gate 2. Okay. So it will change state 1 to state 0. Means no power supply is there. So we applied 2 NOT gates. So this is NOT 1, X1. Again, we applied X2. So 2 NOT gate, if you apply next to next, it will cancel each other. It will cancel each other. So if you want to understand multiple gates step by step, you can enable this inspect option. So all of you note here, inspect option is there. So enable. So it will start from beginning. So stage 0. Okay. So click next. What happens? It will move to first NOT gate. So from stage 0, it will move to state 1. So this is done by X1. This is done by X1. So next what we will do, click next button, next layer, it will move to next NOT gate. So this is X2, this is X2. So it will move from here to stage 0, X2. So if you want to understand multiple gates, layer by layer, you can enable this inspect option. You can enable this inspect option. So disable this, then only able to edit your circuit. So in inspect mode, you cannot able to edit your circuit. So don't get panic. Okay, disable this. So select this NOT gate, press delete button. Select this NOT gate, press delete button. So this is about 1 qubit. This is about 1 qubit. Now what we do, we drag and drop Hadamard gate. We drag and drop Hadamard gate. So what is the theory of Hadamard gate? It will create equal superposition. So look at here, at the same time it is pointing to North Pole, it is pointing to South Pole. So this is like in equator. Equator, right? The equator means it is pointing to both North Pole and South Pole. So in Q-sphere, little different representation. Okay. Now we can see, excuse me. Yeah, sorry about that. Basically, we can see. So we start from stage 0. As usual, we start from stage 0. Okay. When you apply Hadamard, it will create equal superposition. I hope I am audible. My slide is visible. Okay. So what it will do, it will create equal superposition. It will go to positive state. Okay. Then one more important thing is there. If you do measurement, so this is the measurement gate. I will highlight. This is the measurement gate. If you apply measurement, superposition state will get collapse. So imagine your qubit is like a soap bubble. Your qubit is like soap bubble. Okay, it is in superposition. When you try to touch that soap bubble, it will burst out. Same way, if you want to do measurement, then superposition state will get collapse. You have two possibilities, right? Either state 0 or state 1. You get only one of this state. So this is important point. If you do measurement, superposition state will get collapse. So in superposition, how many states are there? So in between state 0 and state 1. So this is AND. Okay, both states you will have. But once you do measurement, you will get superposition state collapse. Either you will get 0, you will get state 0 or state 1. So this is in binary form. Okay, so this is the meaning. So in upcoming session, maybe the experts will clarify you what is the meaning of measurement in quantum. So right now, this is more than enough to understand. Now what we do, we try to select this measurement, press delete button. Again superposition you can see. Against this measurement will convert your quantum information into binary form. So you need to think in this way. When you do measurement, your superposition state, your quantum state will go forever, will last forever, which will turn into possible binary outcome, binary data. Okay. So go to view, go to panels, enable state vector, go to view, go to panel, enable probabilities. So resize your window. Now try to understand this. So delete Hadamard gate. Now your circuit is empty. Now you're pointing to stage 0. Stage 0 means look at key sphere. I will take highlighter. Look at key sphere pointing to North Pole, empty circuit. So look at the state vector. What is your signal strength? Signal strength is full for 0. So full amplitude for your 0. Okay. Look at the probability. I'll change over here. Look at the probability. So probability is 100% for stage 0, binary value 0. Okay. Now what do you do? Drag and drop NOT gate. You can see changes in all these window. All this window. Okay. So it is pointing to South Pole. Now amplitude shifted to state 1, full amplitude. Okay. Now the probability stated to state 1, 100%. Okay. Now delete this NOT gate. Apply Hadamard gate. Now we can see the theoretical explanation. So if you implement Hadamard gate, what happens? Equal superposition. Okay. Same time it is pointing to stage 0, 50%. State 1, 50%. Little difference will be there, not exactly 50-50. Some randomness. Okay. So theoretically 50-50, but practically not exactly 50-50. So state 1 will have amplitude 0.707. Okay. Stage 0 will have amplitude 0.707, which is equal to, so recall the block sphere, 1 over root 2. So this value is 1 over root 2. So if you take modulus, if you do square, you will get probability, which is 0.5. So if you want to convert your amplitude into probability, what you're supposed to do, you need to take modulus and you need to do square. So I hope everybody able to follow. If you add these two, it will lead to 1. If you add these two, 0.5 plus 0.5 lead to 1. Okay, so whatever you do in this circuit, equivalent coding will be get generated. So go to panel, go to editor. You can see Python code is over there. So click Biscuit, you can see Python code. I drag and drop Hadamat gate. That is why circuit H contains Q register 0. So drag and drop NOT gate, you can see update in coding. Drag and drop I gate, you can see update in coding. So this you can learn the basic stuff using IBM Quantum Composer. So in future, you need to write coding. So before this, you can have the baby step by using Quantum Composer. I will stop over here. I will open for questions. Thank you all for listening patiently. So 1.5 hours is nothing. We are not able to cover the entire stuff. So if you want to have the follow-ups, I can share my social media ID, LinkedIn. I am very active in LinkedIn. So you can follow me. You can give connection request. It's up to you. Thank you all.
So thank you for this excellent lecture. I think we already had some questions over the chat. If
Okay,
anyone want to ask the questions, you can unmute yourself and ask the question also.
Sir, very good evening, sir.
Good evening, ma'am.
Sir, this is Dr. Kotlavani from Guru Nanak, Hyderabad.
Okay.
Actually, I'm very new to quantum computing, sir, and
Yes, ma'am.
I'm trying to learn quantum machine learning.
Okay.
In previous session also, that sir showed me as showed in the particular PPT as in quantum the major factor is inference. Because of inference, only they are leading to quantum part likewise.
Okay.
But my question is, even though we are having machine learning, deep learning, and about your data sciences everywhere, we are planning and playing a lot of algorithms with the data.
Okay.
But is there any possibility to club the deep learning and machine learning along with quantum, sir?
Definitely, a lot of possibilities are there. A simple example I am giving. We are doing chemical experiments in chemistry laboratory. We cannot do those simulation by using supercomputer. A simple chemical reaction, what we are doing in chemical lab, we cannot able to simulate using supercomputer also. But in quantum, we can able to do. So trying to understand the quantum computing for 6 months or 1 year, then slowly, gradually move to quantum machine learning. So whatever you do with the deep learning, machine learning, CNN, you are able to do in quantum. Little bit difference will be there. Little bit difference will be there. But you need to invest whether your problem is worth enough to do in quantum.
Okay,
To learn
because
quantum, it will take 6 months time. 6 months time minimum.
Because I'm having one small personal experience, sir. Because my husband is working in mechanical engineering department.
Very good.
So he did his second PhD related to materials.
Material, okay.
Yes. So the data what I got from that project is SEM image.
Okay.
It's not like whatever the data set we are calling in computer science.
Okay.
It is same as a SEM image, but we tried the same thing with machine learning and deep learning.
Okay.
That is possible. I didn't say that is not even possible with machine learning and deep learning. It is possible with machine learning and deep learning ideas. But
Okay.
when I am trying to utilize the complete SEM image in deep learning structure,
Mm-hmm.
I can't able to use that mathematical part and whatever the deep learning models effectively, sir. I got a
Okay.
result, but it's not an exact result.
Okay.
Then my professor suggested this quantum machine learning, but I don't know the zeroth level of quantum even.
That
I'm
is why
okay
that
with
everybody in this forum are very beginner to quantum, including myself. So you need to start from scratch. If you're studying quantum for first course 1 and course 2, within 6 months or 1 year, you will have idea how to approach quantum for your problem. So there is no ready-made solution for all our problems. So it needs some time. So if you need more information, you can contact me. You can contact any resource person in this session. Thank you, ma'am.
sure, sir. Thank you so much, sir.
Any other questions? Yeah, very good area. So whatever you do little bit in quantum, they will recognize you. So you need to have a lot of patience. So quantum is not explored, unexplored. So you need to have a lot of patience. You need to study a lot. You need to do a lot on trial and error. So no ready-made solution for all your problem statements. So that is why it is very hot in research. Still 15 to 20 years quantum will be in R&D. So practical use it will come after only 15 years. Okay, any other questions? Thank you all. Thank you.
No questions. We can close the session. Thank you, sir. Thanks for joining us. It was a very insightful talk, and you explained it beautifully with all these links and all these things. I'm
Sure, sir,
sure we
sure.
are going to go back and look at the recorded video once again to understand even better. Thanks a lot.
Thank you all also.
So, dear participants, thank you for joining. So, there's no need for attendance. I think we will take it from WebEx itself directly. And the feedback you can fill on 24th in the ATAL portal. And regarding the pre-assessment, whoever has already filled, that is enough. So, someone has not done it, that's okay. That's not a problem, because for the final certificate, only your post-assessment after the FDP matters. This is only just for the sake of some statistics. Okay. Any other questions you can just post. Thanks for joining. Good night. We'll meet tomorrow at 6 p.m.
So, sir, feedback link is with the ATAL portal itself, sir.
I think that's what I heard, that on the last day it will be enabled. Even I am not sure. Let's see on 24th we will see what happens. Yeah.
Actually, last ATAL FTP also I attend through IIT only, sir. They said
Okay.
also like that, but
Okay.
no other feedback links got enabled, sir.
Sorry.
They posted, no other feedback got enabled in ATAL, sir. So they personally posted in WhatsApp only, sir. Means like during session, they posted
Okay.
attendance link. No other attendance link will be enabled in ATAL, sir.
No, attendance
It's
link won't
about
be enabled. That I know. Attendance we will take from WebEx. That is okay. WebEx itself will give us that. We will take it later. I think for feedback, I think it will be enabled in ATAL portal on the last day. That's what I heard. Anyway, I will cross check and let you know.
Okay, sir. I don't think so, sir, because we didn't apply anything. Last ATAL also I attended.
Okay.
I don't think so, sir.
Okay. If it is not there on last day, we will take the feedback. Not a problem.
Sure.
Okay. Thank you.
Good evening, sir. This is Dr.
Yeah.
Beulah.
Yeah.
Some institutions who are conducting this ATAL FDP, they are creating their own feedback links and they're being posting at the end of the session, sir. So only all are asking about the feedback link.
Okay. Okay. Then, okay. We will find. We will try to do it. Okay.
Okay. Thank you, sir.
Thank you.
of the number of bits.